In this short tutorial, I'm going to explain how to work with hypotheses which are expressed in terms of either ratios or percentages. So here I have some theoretical percentages. So some theory says that in a particular population 50% of the snails should be small and 25% should be medium, another 25% should be large. An alternative and identical way of expressing this is in ratios. This says that for every single large snail there should be 2 small snails, and for every large snail there should be 1 medium snail. Okay, to work with this and to derive the numbers of snails we expect to see, we need to know how many snails we've got in total. So I'll assume that, as in the previous example, we have 42 snails in total. All we then need to do is to multiply that total by our percentages to get the expected values. So 50% of 42 is obviously 1. To get a quarter of 42, well, 42 divided by 4 equals 10.5, or alternatively 42 times 25 divided by 100 equals 10.5. So we expect 10.5 medium snails and 10.5 large snails. As a check on our calculations, if we add those three numbers together, try that again, 21 plus 10.5 plus 10.5, we've got 42 snails, the total number of snails we should be seeing. To work with the ratios, we need to add them together to start with. With percentages, we know they add to 100 because that's how they're defined. With these ratios, if we add these up, we get 2 plus 1 plus 1, so that's 4. So 2 out of our 4 snails should be small, 1 out of 4 should be medium, and 1 out of 4 should be large. So I think you can see straight away that it doesn't matter whether we use the ratios there or the percentages. These values here are equivalent and they'll give exactly the same expected values here. In a tutorial problem or a mark problem or examination problem where we had this type of situation, once we had derived our expected values for these different categories, then we would compare the observed and expected using the chi-squared test.